Hello, my name is Johnson Thomas and I'm a faculty member in computer science. Today we will be looking at implementing a database in a whole chain traceability system. In particular, we'll be looking at the security aspects of such a system. Now, there are two ways to implement a database in a whole chain traceability system. One is to use a distributed database system. In a distributed database system, the data is distributed across multiple sites. So, for example, there may be a site that stores process data. Another server at a different location may be storing producer data. Yet a third site may be storing customer data, and so on. So each site is self-sustaining to a large extent and is responsible for the applications that run on the site, for email access, for backups, for internet access, and so on. A second approach would be to use a centralized or data silo kind of approach. Here, all the data is stored in one location or on one server. The big advantage of the distributed system is scalability. As it is spread across multiple sites, scaling it up is an easier proposition. However, there are a number of issues which make the distributed system more difficult to implement. One of them is backup. Now, each site defines its own backup policy. So some sites may be backing up at very regular intervals, whereas others may back up rather irregularly and not very often. This can lead to data loss and data unavailability. Another issue would be the issue of external access. Each site will control internet access, the kind of firewall security and other security mechanisms it has from the outside world. The third problem is the problem of security itself. Is the data going to be all encrypted, or do we just have a simple password kind of mechanism to protect the data? Again, different sites will have their own policies for this. The fourth problem is inter-site communications. Tracing a particular product may require the different sites to communicate with each other, and a secure inter-site communications protocol is required. So given all these four factors, having a uniform policy becomes difficult to implement. On the other hand, in a centralized system, as it is under one control, one central command, so to speak, the problems of external data access through the internet, backing up of data, encryption and security of data can be clearly defined. The policies will be well defined and will take into consideration all the requirements of all the stakeholders of the system. There is no need, furthermore, for a secure inter-site communication protocol, as there is no such communications. However, there is one weakness with the centralized scheme, and that is if someone breaks into the system, then the whole data may be compromised or made available to the attacker. At the same time, it is also important to remember that in a distributed system, the weakest link in the chain is the site which has the weakest security and protection. So an attacker could launch an attack at this weakest site and use that site to launch attacks on other sites which may be better protected. Now, information and data about the databases or the different sites is held in a global registry. When a particular product is to be traced back, the global registry is consulted to determine where the relevant data is held and what kind of data it is. Now, in a distributed system, updating such a registry is more difficult. The registry will be getting information from different multiple sites, and keeping it up to date and maintaining it is more difficult than in a centralized system. Then there's a problem of physical security. What is the guarantee that the server is in a secure server room? This is obviously more difficult if there are multiple servers or in a multiple site distributed database system. On the other hand, in a centralized system, it is easier to guarantee or ensure that the server is located physically in a secure server room. And there is one large issue which looms over all of this, and that is the question of trust. Each site will have a trusted party or a trusted person who has access to all the data and all the information in the system. This is necessary and essential because if something goes wrong, this one party or person can access the database and find out the problem and correct it. In a distributed system, there will be multiple such persons or parties, one at each site. However, in a centralized system, there will only be one such party at that one central site. Therefore, establishing trust or confidence in a distributed system is much more difficult than in a centralized system. The trust in the system is determined by the weakest link in the chain. All the parties may be trustworthy, but if there's one party in a distributed system who is not dependable or trusted, the whole system loses trust. Given some of the advantages of the centralized model, the National Whole Chain Food Traceability System implemented here at OSU is based on the centralized model.